In this video, we'll go over an example of how to write the equation of a tangent line when you're given a function. So this is the original function, and we want to find the tangent line, the equation for the line that's tangent at x equals 2. So anytime you want to find the equation of a line, it resorts back to what you learned in algebra. This is the point-slope equation. That's the easiest one to use because all you need is a point and the slope. So in this case, the x-coordinate of our point is 2 because that was given to us. So the y-coordinate would be f of 2, which is plug in a 2 into your function, and that gives you the y-coordinate. If x equals 2, then you plug it in, you get the y. The slope is the derivative at x equals 2. So let's start with the easier one, which is the point. This is the y-coordinate. So we just plug in, we get 2 times 8 here, and then minus 4 plus 2. So the y-coordinate is going to be 14. The derivative, now you have to use the power rule. The power rule is take the exponent, bring it down to the front, multiply by whatever's here. So in this case, it's a 2. So 3 times 2, and then subtract 1. So this ends up being 3 times 2, and then to the second power. This one, bring the 2 down, and then subtract 1. And technically, this is a 2x to the 0 power right here. So it just ends up going away. There's no x there. So when you do the derivative, it's really like 0 times 2. So it's just gone. So this is really like a plus 0 here. So the derivative of a constant will always be 0. And remember, if you remember from the last video, the definition of a derivative is the slope of a tangent line. So if we were to graph y equals 2 is a horizontal line. The slope of a horizontal line is 0. So that's why this part of the derivative is just 0. Okay, so here's our derivative equation using the power rule to find that. And now we just need to plug in a 2 so we can get the point, or the slope at the point x equals 2. So this will be 6 times 4, and then 2 times 2. So the derivative is 20. So that's it. You just plug in what you know. This is going to be a 2, this will be a 14, this will be a 20. And that's really it. If the directions don't specify to solve it for y or to write it in slope-intercept form, you can stop here. You don't have to go any further. This is the equation of the line. Just because it's not solved for y doesn't make it any less of an equation of a line. So just depending, though, you have to read the directions carefully. If it asks for slope-intercept form, then you just need to distribute and then solve for y.